Hello everybody and welcome to the second part of our substitution method video. I hope the first part made sense. Now let's look at a bit more complicated examples. So let's look at fractions. First thing I'll do, number my equations. Again, that's just for organization. Do you like working with fractions, people? I don't like working with fractions, so let's not. So the nice thing about equations is that you can change the look of them, right? We can make these equivalent equations. So what we can choose to do is we can choose to change the look of these and make them look like, or write them in a way that they don't have fractions. So we can make them look like the previous example, the whole numbers, and then we can solve from there. So really we just have to add a step at the beginning, which is going to be changing these from fraction equations to non-fractions, and then from there, everything will be the same. So, first step. I have to look at the denominators. So I'm going to check out the denominators in my first equation, and it's 2 and 5. Well, in order to multiply by the correct number that's going to change all these fractions into whole numbers, what you want to do is you want to think about, or you want to multiply by the lowest common multiple of those denominators. So that's what that LCMD represents, the lowest common multiple of the denominators. And you want to think about this. If you make a multiple list of 2's and a multiple list of 5, what's the first number that would appear in both lists? Well, the first number that would appear in both lists is 10. The other way you can do it is you could also just multiply your bottoms. Now, by multiplying the bottoms, in this case, it's the same answer, 2 times 5. In other cases, it's not that you'll pick the wrong number. You'll just pick a larger number than you needed to, and that's not an issue at all. So if you just want to multiply the bottoms instead of thinking about what the lowest common multiple of the bottoms would be, that's fine as well. So we've decided on our magic number, our number that's going to help us change the way this thing looks. So I'm going to take my first equation and I'm going to multiply it by 10. So I'm going to write 10 over 1 times 1/2 x, and it's a positive 10, so I'm going to write positive 10 over 1 times this negative 4 over 5y equals now positive 10 times negative 2. All right, so now it's all set up. Now I'll go through and multiply. So I like to reduce when I multiply. So I'm looking at the 10 and the 2 that I've crossed out, and I'm noticing that they have a common factor between them. The common factor would be 2, so I can divide them both by 2. I end up getting then 5x. Now, if that didn't make sense, by all means, just multiply straight across and go 10 times 1 is 10, 1 times 2 is 2, 10 over 2 still equals 5. So no matter which method you use, you're going to get the same answer. The next one, a positive times a negative is a negative. And then I look at the 10 and the 5, and I can see that they both have a common factor of 5. So if I divide the 5's out, I'm left with a 2 and a 1. And then now 2 times 4 is 8, so I get 8y equals now 10 times negative 2 is negative 20. All right, so there's my first equivalent equation. So I have a new arrangement, so I'm going to give it a new number. And now, remember, what that means is I can use this equation moving forward. So it's the same line. So if I was to graph equation 1 and equation 3, it would be the same line. Just that equation 3 is nicer to work with. All right. Let's work on this second equation. I want to think of the lowest common multiple again of its denominator. Well, if I made a lowest common multiple list, if I just count by those numbers, the first number that would appear in both lists, and you could see it already, was 8. So my lowest common multiple is 8. Now, if you were to use that multiplication trick we talked about previously, just multiplying my denominators, 4 and 8, I'd get 32. So I can use 32 or I could use 8. 8 is smaller, which in theory means the multiplications will be easier, so that's nice. But if you're okay with multiplying with 32 instead of 8, then there really is no difference between the two methods. So I'll take equation 2. And I'm going to multiply by 8. Again, I like to make these little notes just so I can remember my thinking. It helps me kind of focus myself. So I'll write now, well, 8 times y. And then now 8 over 1. So I always match my 8 up. If it's a fraction I'm multiplying it to, like 1/4, that's a fraction, I'll write as 8 over 1. Again, remember it's a positive 8, so I'm going to write 8 over 1 again because I see that I have another fraction, which is 3 over 8. Okay, and I'll start multiplying, so 8y. This time I won't use my shorter multiplication route. In case that confused you, I'll multiply kind of the old school way. I'll multiply first, then reduce. What I was doing was reducing first, then multiplying. Anyway, I would get 8 over 4x. And then over here, I would get 24 over 8. Now my next line, 8y equals I then reduce it, 2x plus 3. So whichever method you want to use. And now that's equation 4. So equation 3 and 4 are way nicer to work with than equations 1 and 2. And I can do that because we've already discussed these are the same lines. Equation 1 is the same line as equation 3. 2 is the same as 4. So I have the same system, so don't feel like you're solving something different. Okay, so now once I have this, I can just get into my normal solving. So I want to check out these two, check out my new system, and I'm just going to maybe write it up here so it stands out a bit more. So I have 5x minus 8y equals negative 20. Like, I like to write this out. I'm on a tablet though, I only have so much space. So I'm going to have to kind of jump around a little bit. I'm sorry for that. 2x plus 3. So this is the new look of the system, and I want to try to find something to isolate so I can substitute it in. Hopefully you've noticed, well, look at, they both have 8y. So this is 8y already. This is 8y. So this one is actually even easier than usual in that my 8y is already isolated and I can use it. So that's what I'm going to do. I am going to sub equation 4 into 3. And let's just draw a line here so you know I just kind of cutting my work off there. So equation 4 is 8y equals 2x plus 3. Equation 3, and I'm just going to write these up again. So this was 3, everybody. This was 4. Sorry, my stylus looks a little bit off today. So I actually wrote the wrong one first, so that's good. I stopped. Let's just do that. I want to start off with equation 3. So that's the 5x minus, and I'm going to switch color here, so I'm kind of glad I made that mistake, equals negative 20. And I'm going to replace the 8y with this 2x plus 3. Now, when I do that, one little thing to remember, it's a subtraction here, so I'll have to distribute that negative sign through eventually. Okay, so now we see 8y is equal to 2x plus 3, so I was able to sub it in. And then now, yeah, I'm just going to solve the equation. Again, I was able to take these two equations and meld them into one equation. And I was able to take the new equation that had 2 variables in it and turn it into a 1 variable equation, which makes it easy to solve. So 5x minus 2x minus 3 equals negative 20. That's now 3x minus 3 equals negative 20. Add 3, add 3. 3x equals negative 17. Divide by 3, divide by 3. X equals negative 17 over 3. All right, so that's kind of an ugly number, but sometimes that happens. Now you might be wondering, I'm just going to draw a line here. So remember, our next step, I'll finish my thought there that I started, but remember my next step is now to find the other part of that vertex. So I'm going to actually sub in, and I hope I have enough room here. I'm going to sub x equals negative 17 over 3 into the other equation now. So I just worked with equation 3 really, so I'm going to work with equation 4. You can always jump back to equations 1 or 2 if you wish as well. It's just a fraction, so it's kind of tougher to work with. Anyway, you might be thinking, well, now I have a new fraction. That's going to suck. You'll see here we can get rid of this fraction as well. So whenever you have fractions and equations, you can always get out of it. So it's not so bad to work with. Okay, so let me get my train of thought back. I'm looking at equation 4. So I'm going to write that down. 8y equals 2. And I'm just going to change that color to highlight what I'm subbing in. 2x plus 3. Okay, and then now 8y equals, and I'm going to have to, like I said, I guess I'll write that as 2 over 1 because I have a fraction coming in, plus 3. This is negative 17 over 3. Okay, so I can multiply to get rid of this. Before I multiply though, or before I get rid of the fraction, let's complete that multiplication that's happening. So 8y equals, that's going to be negative 34 over 3. plus 3. All right, so if I want to get rid of the fractions in this equation, all you have to do is multiply by the lowest common multiple of your denominators, but there's only one denominator, it's that 3 here. So I'm going to times this whole thing by 3 simply. So you can show it or you can just kind of talk about it. Like 8y times 3 is 24y. This is me not showing it, just doing it. When I multiply 34 times 3, what's that? 90 and 12. Hey? So negative 102 over 3. And then plus 9. Keep going through it. 24y equals negative 34 plus 9. And now I can just solve for that y. Sorry, I'm getting kind of tight for room here. 24y equals, that ends up being 25, I guess. So divide by 24, but divide by whatever's in front of your y. So my y equals 25 over 24. Okay, so there is my point of intersection. Now, you might not feel as confident with it because you're dealing with some fractions, so we can always check this, all right? So why don't we check this? So I got hello again there, guys. Sorry that likely looked really jumpy. Let's check this. I actually didn't feel like that was right, so I just double checked my math here, and this is right, negative 17 over 3, and you likely saw it as well. That should really be negative 25 over 24, not positive. I kind of missed that negative there. Not a big deal. So let's check it. I'll check it with equation 3 first. So I have 5x minus 8y equals negative 20. I will sub in my fraction answers. Minus 8 over 1. This is now negative 25 over 24 equals negative 20. And get doing the work here. I get negative 85 over 3. This is now going to be a positive. Like I said before, I'm going to reduce this. So I get positive 25 over 3 equals negative 20. And then now I lucked into some common denominators there. So if I go negative 85 plus 20, actually plus 25, sorry, I would get negative 60 over 3. And the right side is negative 20. And that reduces to negative 20. So there we go. That point definitely works with that line. We'll check it with the other one really quickly here. 8y equals 2x plus 3. So 8 over 1 times negative 25 over 24 equals 2 over 1, the x value, negative 17 over 3 plus 3. Go through and start doing my math here. 1 and 3 again. So that is going to be negative 25 over 3, which we already knew from doing that in the previous question. This one here, so that would be negative 34 over 3 plus 3. Now, let's say you don't like the fractions and this is confusing you. Well, then multiply to get rid of them. So you don't need to here, but let's say you just didn't like it. Again, check out your denominators. They're both 3s, so I just multiply the whole thing by 3. So I'd get 3 over 1 times negative 25 over 3 equals 3 over 1 times negative 34 over 3. And then plus 3 times the original 3. And then if you don't like my reducing first method, so I would just go straight across. I get negative 75 over 3 equals, what is that? That is 90 and 12. So negative 102 over 3 plus 9. And then I can reduce those. So that's going to work out to negative 25. That works out, negative 102 over 3 works out to negative 34 plus 9. A little bit more work to do. My left side's already done. Let's finish the right side though. Negative 34 plus 9 actually ends up being negative 25 as well. So then I know my answer is as follows. It's what we thought. Negative 17 over 3 and then negative 25 over 24, which are really strange answers, might feel wrong to you. So this is a great example. Number one, to show you can get some weird answers. And number two, to show you a good time to check. Like if you feel like the question's easy, maybe you don't have to check it. But if you feel like it's kind of odd, check it. So same process as before. I have some fractions in these equations. I don't like them. I'm going to write a new system, an equivalent system. So equation 1, equation 2. I want to check out my denominators. So it's 3 and 2. So the lowest common denominator. If I made a list of denominators, or sorry, multiples of 2, and I made a multiples list of 3, you can see the first number that pops into both of them is 6. So my lowest common denominator is 6. In my second one, my lowest common multiple of the denominator. You can see it's 2, 4, and 2. So hopefully, if you're making one of those lists, you'd see that the first time, well, I can make it myself, I guess, up here as well. Here's 2, 4, 6, my multiples of 2, then my multiples of 4, 4, 8, 12. And the first number to pop up into both of them is 4. So those are the magic numbers I'm going to multiply by. So now we'll proceed with making nicer looking lines. So 6 for this guy. So 6 over 1, 2 over 3x, plus 6 over 1, negative 1/2 y, equals 6 times 4. I didn't write it as 6 over 1 because 4 wasn't a fraction. 12 over 3x minus 6 over 2y equaling 24. So then I get 4x minus 3y equals 24. Okay, that'll be my new equation 3. I don't quite have enough room, I don't think, for this to write the next one down there. So I'll take my equation 2 now, and I'm going to times it by 4. I never really wrote that down there, so I'm multiplying that one by 6. So I go 4 over 1 times 1/2 x plus 4 over 1 times 1/4 y equaling 4 over 1 times 5 over 2. Okay, I'll go through and multiply, so I get 4 over 2x. And I'm taking the long way multiplying here. If you like to reduce before multiplying, that is way better in my opinion, but I don't want to lose people in the video, so I'm going to shy away from it. And there is an equivalent equation for equation 2. Now we'll call that 4. Okay, so now if I look at this, I can see, thankfully, it's nice when you have a lone variable. So I know my new system, and again, maybe I'll write the new system up here. Again, I'm short for space, so I'm going to kind of put them up here just out of the way. 4x minus 3y equals 24. And then the other equation, 2x plus y equals 10. And if I didn't have that lone y, let's just play that game for a second. Well, what I could have done is I could have focused in on the x's, and I could have rewritten 4x as 2 times 2x, and then isolated the 2x here. Okay, so that's what I would have done if I didn't have a lone variable already, but I already have that y, so let's just work with that. So I'm going to take equation 4, and now I have 2x plus y equals 10. Subtract 2x, subtract 2x. Y equals negative 2x plus 10. I have a new arrangement. So now I have a third equivalent equation for that line. And numbering wise, I'll just keep going up by 1. So that's equation 5. Now if you're thinking, didn't it seem like less work the previous example? It was, because we had kind of a special system that was already isolated in that last example. So in this time, there wasn't anything kind of set up for us. We have to just keep solving. So now I'm ready for my substitution. So I can sub this equation 5 into the other line. So you got to kind of keep track of things. I know that that equation 2 turns into equation 4, okay, which then turns into 5. So 2, 4, and 5 are all the same line. So I want to look at equation 1 or 3 when I move forward. So 3 is a nice non-fraction version. So I'll end up subbing my 5 into 3. So I'm just going to pop over to a new screen to do that. Okay, so like we said, we're going to sub 5 into 3. So 3 is 4x minus 3y equals 24. And so now that's going to become 4x minus 3 bracket whatever. I'll leave room for that new expression to go in there. So y is equivalent to negative 2x plus 10. So now again, I've done my job. I've turned this from a 2-variable equation into a 1-variable, and then now I'll just go ahead and multiply. So 4x plus 6x minus 30 equals 24. That's 10x now minus 30 equals 24. And now I'm just taking my time. Again, there's nothing new with what I'm doing now. Everything that was new was really turning the fractions into non-fractions, whole numbers. 10x equals 54 divided by 10 divided by 10. And you can leave it as 54 over 10 if you wish. You could also, they're even, so I'll divide them out. So 27 over 5. But really, 54 over 10 and 27 over 5 have the same value. So to me, it doesn't matter. It's an advantage to reduce when you're going to carry that number forward and keep working with it. So now that I've got x, now I will sub that in. Sub x equals 27 over 5. And I just worked with that the line that was equation 1 and 3. So now I'll work with one of the other ones, meaning I can work with 2, 4, or 5. And really, it is your choice, whatever you feel like working with. I'm just going to pick 4. I just work with the other line, so whatever version you want to work with. So I'm going to have 2 over 1. I'm going to kind of cheat here, everybody. 2 over 1 times, I don't know why I don't really have to do that. I'm going to just leave it as 2. So 2x plus y equals 10. Now I can write it as 2 over 1. Leave room for that fraction. Plus y equals 10. So that is 27 over 5. So do the math. Now I got 54 over 5 plus y equals 10. And I don't want to work with these fractions, so what I can do is just multiply this whole thing by the lowest common multiple of my denominators. Well, there's only one denominator, it's 5, so multiply everything by 5. So I end up getting so 270 over 5, which is an enormous number, but don't worry, that'll reduce. And then 5 times y is 5y, and 10 times 5 is 50. And then 270 divided by 5 reduces back down to the 54. So a shorter cut would have been using my reducing first model, but we won't get into that right now. This video will be long enough already. So now here's my fraction-free version, and then I'm just going to go through and work it out. So that's negative 4, I guess. So y equals negative 4 over 5. And there we go. If you don't feel comfortable with that answer, then you can check it. We showed how to check it last example. It'd be the exact same thing. Always make sure you get your your x value coming first. Sometimes people will write whatever their first answer in the first position of their vertex, but remember we want the, sorry I said vertex, the first position of their point of intersection, but we want the x value. It might have been the second thing you found, but we want the x value there. Okay, so that's 2 good examples of how to deal with these fractions. Okay, everybody, that's it for this video. Hopefully that made some sense. You can see that the substitution method doesn't really change when there's fractions, just that there's one more step we'll do at the very start to get rid of the fractions, then we go into the normal method. If it didn't make sense, make sure you talk to your teachers or come find me. Have a great night.